Okay, this is a quick review of microscopes and the parts, and this shows a picture of the two microscopes that we have in our class. We have compound light microscopes, and this one right here has a traditional stage with the stage clips, and this one right here has a mechanical stage, and with these knobs you can move the slide back and forth very gently. It's a little bit more precise with its movements, but it's also a little bit harder to get used to. So these microscopes are called compound light microscopes, and they're compound because they have two lenses, one at the top and one near the specimen that you're looking at. The top eyepiece that you look through, the top lens, is called the eyepiece or ocular objective. For all of the microscopes in our classroom, these are 10x. This is written on the side of the eyepiece, and as a reminder, it tells you that it's multiplied 10 times. The other objectives are located just above the stage, and there's three different kinds. We have one that's a 4x, a 10x, and a 40x. The magnification is written on the side of these objective lenses. They are objective because they are over the object that you are looking at, and this can help you know which one. Also, the one that is the more powerful one is longer than the one that is the lowest power, and when you see these, not in a picture like this with perspective, you will obviously see that the 40x is bigger than the 10x. If we back up a little bit, again, this is the 40x and this is the 4, and then the 10x one is on the other side where you can't see. The nose piece is this circular part right here that holds those lenses, and it spins. When you spin it, you have to be sure it's clicked into place, otherwise you won't get a clear view through the slide. And the barrel is what connects the lens to the rest of the microscope. And this is the arm, and it holds the objectives over the stage, and it's also helpful to carry. When you carry your microscope, you put one hand near the arm and the other hand should be supporting the base. For calculating total magnification, you multiply the number on the eyepiece, which in our classroom will always be 10, and the number of the objective that you are using. So 10 times 10 equals 100x. The x here means times magnified. It's not a variable like it is in math. The two types of stages, it's very important here that you use whichever one you have appropriately. The traditional stage has stage clips, and the slide goes underneath the clips. Those are held in place. When you want to move the slide, you have to do that by just moving it with your fingers, and it moves the slide in the opposite direction that you are looking. So just bear that in mind when you are trying to find a specimen. With the mechanical stage, you have to open this little arm that moves, and the slide fits just inside. It does not go underneath the parts of the frame here. The frame just holds the slide in place. There's another picture that will show you that a little bit better. To move the mechanical stage, there's two little knobs. This one moves the slide forward and back, and the other one moves it side to side. You should try those out. They move them very, very slowly, but that's so you can not lose a specimen that you're looking at if you are moving it around while you're looking through the microscope. This is a close-up picture of what the slide looks like in the mechanical stage. This slide does not go underneath these two borders of the frame, unlike the stage clips. So it's a little bit confusing, but just don't put those underneath. If you do, these can get bent, and then when you move the stage, it just slides over the top of the slide, and it doesn't help move the slide. So be very careful of that. Here's a picture of the stage with the stage clips, and those go gently on top of the slide. You don't want to snap them around because you don't want to break the slide, so just be careful with those. If you move down and look underneath the stage, you see this little wheel with holes in it. This is the diaphragm, and it allows a different amount of light to go through. If you are on a higher power, you might need a little bit more light. If you're on a lower power and you have too much light and the slide is washed out, then you can decrease the brightness. You can also accomplish that by this little dial that's on the base of the slide, and it's a dimmer switch. This is also a good thing to check if you ever turn on your microscope and you don't see light and you're sure that it's on. Check your dimmer switch that it hasn't been turned all the way down. Again, here's the base, and you can see the dimmer switch right here. It's kind of hard to see if you're not looking for it. The base is weighted. It gives the microscope stability so it doesn't tip over. And on the back we have the on-off switch. So the first thing you should do when you go to your microscope is check that it's plugged in and that the on-off switch is on, and when it is, it will glow a little bit so you know that electricity is getting through. If it's not green, like with a little light on, then you'll know that there's an electricity problem as opposed to your microscope having a problem. When you're all done with your microscope, it's important to remove any slides that might be on the stage, put the low power objective in place, turn it off, unplug it, and cover it, and then loosely wrap the cover around, the cord around the outside over the cover. It helps keep the cover in place and it doesn't get the cord all tangly underneath. You don't want to tie it into little knots and make it difficult for the next person. And then when you put it away in the cabinet, you want to be very sure that you are gentle and are careful that you're not hitting the eyepiece lens on the cabinet above, so you don't want to break it. So just carry it with two hands, be very careful, and thank you very much for taking good care of our classroom microscopes.